So we'll go through Magento 2 and what to actually expect as a developer. So before we start, I'm James Cowie, a technical team lead at Session Digital. Been working with Magento 2 since the developer beta started in January, where we went to Berlin and provided our feedback, but also been more actively involved in some of the projects that we've been working on recently, which are actually utilising Magento 2. So before we look at actually what's new in Magento 2, let's see what changed since Magento 1. So the biggest thing that actually changed since Magento 1 was first created is the language itself. PHP has changed in the past 8 years. In 2009, we got namespaces. We've had the introduction of Composer, traits, type hints, namespaces, all parts of the language that weren't available when Magento 1 first was created, and what we've now got empowered inside of Magento 2. But it's not just the language itself that's changed, it's the world of software engineering that's changed as well. A lot's changed in 8 years. The way that we actually deploy our services online, how we've got cloud architecture was only a dream back 8 years ago. We had to rely on physical tin in service data centers. We've got test-driven development, which thanks to the likes of PHP Unit, PHP Spec, BHAT, they've all helped evolve our TDD, BDD process to be more the norm as opposed to the exception. And more recently, we've had the advent of domain-driven design, which is impacting how we actually design our code, how we think about the models that we're using inside of our application. And if we look at how we actually installed Magento 1 8 years ago, not much has really changed to how we install a Magento 1 project 8 years ago to how we install a Magento 1 project now. It was a monolithic application. I bet there was quite a lot of people that actually scripted this process by creating individual seed repositories where they could download the project files from, or they'd have to go to magento.com to download the archive to then create a brand new project. It was never thought to be a composable application where we could take individual bits and reliably and repeatably install that same application. Thankfully, Composer came along in the time that Magento 1 and Magento 2 is being built. So Composer was built by Jordi Boggiano in 2011 as a way of actually managing project dependencies in PHP. He wanted a tool that could actually allow us to install dependencies and pin them to versions so that we could reliably and repeatedly install projects regardless of what system we were installing them on. If me and another developer wanted to install the same packages, thanks to our composer.json file, we can actually repeatedly do this process. So if we look at how we actually install Magento 2 now, remembering that we used to have to download the archive from magento.com or create our seed repository, in Magento 2, because of Composer, we can literally just go to our command line interface and call Composer create project, specify the stability that we want to use, choose the community package that we want to install. So this is the package that we're using from Packagist. So we're saying the project community edition and the folder that we actually want to install it into. That's all that we actually need to do to get a Magento 2 installation off the ground. What that actually creates for us is a Composer manifest file. Inside it, the most important part is the require section, where we can see the version of Magento that we're installing, the actual Packagist namespace, and the merchant beta, which is the version that we want to pin it to in our composer.json file. So no matter how many times we run Composer install, we're always going to be pinned to that specific version of code. No more do we need to worry about whether the SFTP version's been updated or not. But Composer can actually do a lot more than just install Magento 2 for us. Composer came with a service called Packagist. So Packagist is one of the online largest collections of PHP packages in the world that we can actually search and use. So in the Magento community, we were so used to having to reinvent the wheel time and time again. We'd build our own PDF library, our own tax rules. We'd build implementations that were bespoke to Magento, but we'd never share with the outside world. Packagist and the Symfony guys had this problem as well. So they created Packagist as a means of us installing packages, sharing the packages, and sharing the common knowledge of the community. So now, using Composer and Magento 2, we can pull in packages from Packagist like never before. All we actually need to do is go back to our command line and call Composer require and the package that we want to pull in, and it's simply added to our Composer manifest file ready for us to use in our code. It's as simple as making sure that we inject the package that we want to use into our constructor, and away we go. No more do we have to deal with Magento 1 using the library folder or even patching the autoloader so that we can implement our own packages from Packagist. We can just download, use, and take on the common knowledge of the community. But Composer comes with another great tool, versioning. So versioning is quite a new concept, especially in software engineering to developers that I know. And to Magento itself, versions came with security patches that we had to get downloaded and applied ourselves. Whereas versioning inside a Composer is a way of managing the dependencies that our project relies on. We can use major, minor, and patch versions to say how stable our project is at any one time. And versioning comes in different flavors. We've got exact match, where we can say that we only ever want that exact version of the software to be installed. If it's Magento 2, 2.0.0 at time of release. We can go for ranges, so we can say that we're happy to go from Magento 2.0 star to 2.1.0. So we can pull in features between the two different releases. We can say we want a wildcard. So a wildcard, in this instance, where we say 1.0.star, will actually pull in any bug fix which is applicable to the software or dependency we're trying to pull in. So if this was Magento 1 2 weeks ago, when we had the latest security fixes, we could have literally just ran a Composer update using the wildcard to make sure that all security patches were applied without having to continuously go and download. Or we can say we want the next significant release. So a rather far-fetched example, but if we're using Magento 1 in a Composer project and we use Magento 2, we could say that the next significant release we'd want to be Magento 2. It wouldn't quite work because of the two different architectures, but it's a way of seeing that we can always pull in the next significant releases via our Composer manifest file. Now versioning is great, but we also need to understand semantic versioning. So semantic versioning is a way of us actually understanding and communicating the intent of our module. It takes three forms: major, minor, and patch version. Major version is what can break backwards compatibility. It's introducing brand new features. So Magento 2 increments the major version from 1 to 2. The next version is the minor version, where we're introducing brand new functionality. So we're not introducing any backwards compatibility breaks, but we're actually introducing new features. So introducing Braintree in Magento 2 will be a minor version. And patch version is where we've got any bug fixes or security fixes. That's where we want to increment the last version. So not necessarily related to Magento 2, but because we're going to make our packages composerable and shareable with the community, it's great to actually understand how we can version our modules so that other communities can actually benefit and offer advice. So we've seen how we can use Composer, how it's beneficial to the Magento core, but how do we actually make our modules composerable? So we now know that all of our modules inside of Magento 2 live in a single namespace. We've no longer got design assets in one place inside of Magento, JavaScript in another place, and code in another place. We've actually got a single composerable archive, which is what we can use as our module. So if you're following along in the merchant beta, we have to use a slightly awkward way of installing our packages at the moment, because at the merchant beta phase in Magento 2's history, they weren't aware of a way of actually using the auto-loading to pull in our Magento 2 packages. So we still had to rely on copying files from the vendor folder, which is what Composer uses, into the app code directory, which is what Magento 2 understands. So what we needed to do was apply the extra map notation, which said, here are the files in our source directory, please copy them into the app code directory under the Session Digital Magento 2 module namespace. So when we ran a Composer install, it actually copied those files and put them in the correct location for us. And for merchant beta, that's working fantastically well. There's no problems, even uninstalling modules, because Composer can understand how to take out those mappings and removes the files as needed. But because of the community effort and Magento 2's effort, they put out a call for help on the GitHub forums, and we're asking for people to contribute and actually pull in auto-loading using PSR namespaces. So what that means for us now is that in our Composer manifest file, we can register a single files helper, which is the file to register our module with, and the PSR namespace, which is where we want to actually use the namespace in our module code. That means that no longer do we have to copy files from vendor into app code. The registration.php file is actually going to take care of that for us and register it with Magento 2's env.php. So if we look at registration.php, It's a boilerplate template that we can copy and paste into all of our future modules. We're pretty much just saying that we've got a component registrar of module, and we want to pass in this namespace. It gets run once on Composer install and registers our module just as Magento needs it. So now we know how to make our modules composable, let's talk about decoupling from the framework. So because we can actually take these modules and use them in more than one instance now, we could use it in a Symfony framework, even though it's a Magento 2 module, we should start thinking about how we can abstract away from the framework, how we can use some of the new Magento 2 features to actually make our modules more portable, more composable, more reusable. And the benefits of us actually doing that is that we get cleaner code. Because our modules aren't coupled with the framework logic, database connections, memory connections, it's code that's bespoke to our business domain. It's easier for us to understand and talk about. The more reusable packages, reusable in the sense of Magento 2, because it's no longer tied to a version of Magento 2, but reusable between the business. If you've got a back of house system that you may want to use some of the sales rules that you've developed for the shop, it's more interchangeable between the two services. It's testable. Because you're not testing the framework itself anymore, you've taken the framework out, you're actually just testing plain old PHP objects, which offers more advantageous effects for actually testing. It's easier to read and it's easier to maintain. It's code that makes sense to the business, not having to understand the framework as well. And that leads us to what we know now as the naked module, or the naked Magento module. It's a module that is naked of framework code. No longer do we need to worry about the database connections. We're abstracting all that away. And we do that in a number of different ways. So the main way that we can make our modules more framework agnostic is by using dependency injection. Magento 2 shipped with its own DI container. So an effort was made to pull in the Symfony 2 container as well as the Zen container, but because of the way that the runtime compilation of dependency injection in Magento 2 works, it was far too complicated. We needed to have factory classes generated at runtime based to create all of our CRUD components. But what this highlighted for us was a real-life example from the Magento 2 core when they ported over a Magento 1 module into Magento 2 was that instantly our dependency injection in our constructor arguments was quite large. This indicates a bit of a code smell. So we've got too much going on in our constructor. Is our class doing too much? What is all the responsibilities that it's actually trying to achieve? And it was great for the Magento 2 core team to come publicly out and say, look, this is how we should be developing our code from now on. Our classes are doing too much. Let's move away into repository models. Let's create interfaces. Let's separate out our concern to classes and make smaller services, because this is what dependency injection showed the developers. And dependency injection in Magento 2 actually replaces the Mage God class. So no longer have we got the Mage factory which does everything for us. We're taking that responsibility of instantiating the objects away from Mage and injecting into the classes. But dependency injection can be overused. We saw that the Magento 1 core team, when we ported the classes over, was still far too big, far too complicated, and it's quite easy to inject far too much into a controller, believing it's the single entry point into your application following MVP. It's easier to move that stuff out into models, into repositories, and keep the classes small, lightweight, doing the one thing that they should be doing well. But it enables composition. So by using composition, we can actually compose our modules of the functionality that they actually require and move away from the olden times of Magento 1 where we favoured inheritance. So before we use dependency injection in Magento 2, we'd either call new logger, which would create a new instance of the logger class, or we'd use Mage get model core logger. Direct instantiation inside of our methods for actually calling these services out. But in Magento 2, all we actually now need to do is type in on the logger interface, pass it in via the constructor argument, and we can use logger at will. That gives us the advantages of being able to replace logger at runtime. If we wanted to use monolog instead of the default logger, we can use di.xml to swap out that implementation. Later on, we'll go through how we can use our dependency injection to swap out the template engine from normal PHTML to use in Magento Twig in 2 lines of code. But it also means this is more testable. No longer do we need to write to the file system to test the logger when we're using our PHP spec or PHP unit classes. We can create a mocked instance of logger. And the benefits are that the class responsibility is now to do its one thing and one thing well. It doesn't have a responsibility of making more classes itself. We can swap the concrete implementations out. We all hear the far-fetched example of changing the MySQL database with a MongoDB, but that is actually possible just by using dependency injection. In our DI.XML, we can swap out our database engine at runtime and theoretically change the entire back end of our system in one configuration. And we can mock dependencies. We've no longer got hard dependencies on the file system, on the database, on memcached, on Redis. We mock them into being file system objects or in-memory objects, and using mocks and testables to make sure that the communication between classes in tests is what we expect. But it's not just objects that we can inject in Magento 2. So most DI containers only can inject objects. Magento 2 can inject strings, it can inject booleans, it can inject any type it wants. So the example that I brought from the core is actually injecting allowed file types into the admin HTML area. But where we found this really advantageous is using API endpoints. So while testing for Gigia, we use a mocked API endpoint, which we inject into our classes at test time. Whereas in runtime, when the application is live, we actually use the live Gigia API endpoint. So using dependency injection, we're injecting strings which are affecting the behavior of our application. And a DI.XML file is pretty simple from Magento 2. The majority of it is copy and paste. You start with your XSD, which is what validates our files, and we then go with the name. So what class do we actually want to inject into? So in this instance, we want to inject into our template engine factory because we no longer want to use the PHTML template engine, we want to use Twig. So we say, whenever this class is loaded, template engine factory, look for the constructor argument, so the argument array, look for the array value, which is engines, and pass in this new class. And what's really interesting here is that this entire work was done by a Magento 2 developer, Cyril Schumacher, on a flight back from Austin to Australia in 4 hours. So without any internet connection, he swapped out the entire template engine of Magento 2 in 4 hours and in 2 classes. So a couple of lines of XML and about 20 lines of PHP. And it's that easy for us to actually use DI in Magento 2 to create enterprise-grade applications. And Magento 2, to complement dependency injection, brought in service contracts. It's a language implementation, which is PHP interfaces, but it describes the public API of the class. So if we think of the service contracts of being physical contracts between developer A and developer B, we're saying that my module will do this, this, and this. These are the methods that you can actually rely on and use, and you don't then have to look into the small print to understand what this module is actually doing. It's a theory called design by contract, and it's a really popular way of designing by interfaces so that you don't have to worry about the actual underlying implementation. So one of the examples from the Magento 2 core is the customer repository. We know that when we call in a customer, we want to call save, get by ID, delete, or delete by ID. They're the common actions that we actually want to make for a customer inside of Magento 2. So we create a service contract or an interface. Those are the only methods that any other module extension needs to actually look at. They don't, in the days of Magento 1, need to create observers or class rewrites to get to the functionality to save. We can just implement this interface and create our new save method. So if we wanted to save to MailChimp as opposed to saving to the database, we inject this interface into the di.xml to override the core behavior so that no longer does it save to Magento backend, we're actually saving to MailChimp. And because of the interface, we always expect there to be a save method. There has to be a public method of save, which all contracts abide by. But when I mentioned the public API of a class, it's great to think about it as the public API of our classes that we're designing and how we communicate with each other. But Magento 2 ships with a really powerful REST and SOAP API. So if you're familiar with Magento 1, to configure the API, you needed to use WSDL.xml. There was quite a lot of configuration and actual implementation to get the APIs working. In Magento 2, we had a PHP annotation of our API, and that public method is available both on the REST and SOAP APIs. There's no more configuration work that needs to be done. We've instantly made our service contracts APIs for the endpoint, so it's instantly portable to be consumed by Angular applications, other web services of the application itself. And tests in Magento 2, so tests are everywhere. In Magento 1, it wasn't possible to actually test. It was doable to an extent, but it was impossible to test the core well. In Magento 2, the developers acknowledged that and have got 100% code coverage of unit tests for the core, integration tests and functional tests across every single module they develop. There's no piece of code that they're allowed to commit that doesn't contain a test. And according to Ben Marks, untested code is incomplete code. It's the manifesto that they're taking it to heart inside of Magento 2. But with the introduction of the new Magento Connect, which will be the marketplace for all modules to go into for resale or download, no Magento 2 module is going to be allowed into Connect unless it's actually contained, wrapped fully in tests. So all Magento 2 developers now need to get in the mindset of using tests, PHP unit, PHP spec, Behat to actually validate that what they're writing is quality code. And in Magento 1, documentation was really sparse. We learned by Googling Stack Overflow, Alan Storm, some of the more advanced developers that shared their extensive knowledge with us. Magento 2 have acknowledged that it's going to be a learning curve for people to get into Magento 2. It's not an e-commerce framework that you can just pick up and run with. It's got a lot of enterprise grade features in there that normal Magento 1 developers may not be exposed to. So they've created dev docs and they've got an entire team dedicated to writing developer documentation that's up to date, meaningful and useful for the entire community, covering all aspects from dependency injection to template inheritance and overrides. It's still a starting point, but it's getting better and it's there for the future. As well as each section of the page has got an edit in GitHub, so if you ever find a typo or an addition that you want to make, it's the public's property to make changes. And Magento 2 is now in GitHub. Magento 1 never was. We never saw what commits went into it. We never saw who put a commit into it or what was fixed in any release. It's public. Every single commit that is ever made into Magento 2 is done directly into GitHub, which I know I was so happy about because we can pull it, we can pull revisions, we can contribute, we can put our own pull requests in there, which many of us have now to fix additions, improvements, do all the work that we want Magento 2 to actually be. And that was my whistle-stop tour of what's new in Magento 2. So thank you for your time.